Hello everyone, so my name is Thomas Cerdreux and I am working with Louis Thierry. We are both finishing our PhD in computer science at École Normale Supérieure in Paris. And our research notably focus on the automatic image processing algorithm. Here we want to give a qualitative explanation of many of these algorithms and see how they can influence the way image nowadays circulate. So classically, the digital revolution have changed our relationship with images. Now, an image can be sent at the speed of light. You can store as many images as you want. We can easily modify image, but we are now facing another revolution with the automatic manipulation of images. So, for instance, here you have like an image of a highway and a painting of Van Gogh. There are the style transfer algorithm that allows to create a new image that supposedly maintain the content of the content image, but taking the style of Van Gogh. Of course, it's a quantification of the style of Van Gogh, but the results are automatic and pretty impressive. And they are also kind of easy to use. You just have to give a content and a style image, and you produce a new image. So here, we will first explain all the image collection that made this progress possible for the algorithm. Then we will review some of this algorithm, and then explain the trains and evolution that they share. Finally, we will give some of the practical consequences for the circulation of images.
Image collections played a central role in the development of program and algorithm that automatically manipulate the images. This collection appeared in the early 90s and were meant for simple applications such as digit, face, and object recognition. Such collections typically consist in thousands of images divided into tens or hundreds of categories, and each image of the collection is annotated to describe its content. For example, for a digit image, each image is annotated with the digit contained in the image. For face recognition, each image is annotated with the name of the face of the person. And for object recognition, each image is annotated with the type of object present in the image. From a circulation perspective, this phenomenon is quite peculiar because this image has circulated a lot between researchers, engineers, and students were meant to be raw material for programs. They were not meant to be looked at. A breakthrough came in 2010 with the apparition of ImageNet, which is a huge collection of 14 million of images divided into 21,000 categories, all that annotated by human. This is a huge work with a huge energy devoted to categorize everything, as 21,000 categories is the half of the existing nouns in the English language. And this release of this collection came in with the annual classification competition from 2010 to 2017 that made possible this progress. And the systems have been constantly progressing over the years of competition to attain the human performance in 2017. And these programs that are able to recognize and to decompose images into subsets and subclasses are at the core of the decomposition and recomposition program that we will present you in the following section. A first kind of decomposition and recomposition computer program is the style transfer that we've already presented for the introduction. Thanks to the developments of the image recognition system with ImageNet, was published the first technique in 2015, and then plenty of other techniques were published, giving a rise to new quantification of the style and to new outputs. A second kind, which is a lot used of decomposition and recomposition program, is the class of image generation program or algorithm. The principle is to distill images from a collection to generate new similar image. And you can see an example here on the left, face from the Celebi collection, which consists of faces of celebrities, and on the right, generated images using a program that used this collection, this Celebi collection, to distill and to generate new images. So one can see a few artifacts in the generated images, but still they are coherent as faces, and we see in some sense some pieces that were placed together. But these were essentially first attempts, and progress has been made, have been made in the last years. And the first image that you see, the first images that you see are generated using a recent program of 2018 and a collection of high resolution and diverse images. And you see that these artifacts have disappeared, and there is a big diversity in the kind of image produced by the program. The generation is not restricted to photorealistic image, as you can see on the bottom of the page. Image generated using a collection of non-figurative painting. Recent progress made possible decomposition and recomposition of a single image into new image. So you don't need a collection anymore to decompose and recompose images. And you can recognize in the bottom the famous Van Gogh Starry Night painting that we use for style transfer. That is on the right, decomposed in two different ways.
Another interesting family of decomposition recomposition algorithm are image translation. So they are inspired from the language translation, where you can go from French to English, and or anything. And now you can go from one type of images to another type of image. So for instance, you can go from a satellite photo to a map. You can go from a black and white image to a color image. And you can imagine pretty much any type of translation. And what is even more interesting is that this algorithm, they are very recent, but yet they are already a kind of commodity. They are a commodity because they require very few examples, and all you need to do is pretty much like the style transfer. You need to change the example, and the algorithm takes care of everything and produce an algorithm that can naturally translate any type of image. For the circulation of image, it means that an image alone now is circulating with all the possible translation that are available. And this is a big change in the way images circulate. Sometimes images have a sequential nature. A painting is a sequence of the small action made by the painter. In the physical world, it's not possible to exchange an image in this sequential format. In the digital world, it is perfectly possible. Recently, a new algorithm, automatic processing algorithm, shows that it was possible for a computer to generate sketches as a sequence of strokes. So here you can see a few examples of such generation. Of course, the examples here are basic, but it is a very important and a game changer in the creative and software industry. So, historically, the first interactive software was Sketchpad, made actually to interactively sketch objects with a computer. So it was in 1963. In 2020, Google launched Magenta project, in which you can interactively draw with a computer. Of course, to step up and go forward and not just draw like basic sketches, this algorithm needs data. So there are two possibilities. Either you collect data from the human, so this was done to draw these basic sketches, and it was a quick draw experiment, and this will preclude some use this new format of images, because for the need of the creative industry to better the algorithm. Or you can also, there exists also like software that decompose a still image into a sequence of strokes. So here, for instance, for the basic symbol here, the algorithm decompose it into a sequence of strokes. So they try to do it on a painting, but it decomposes it in a sequence of small action, but still it's not yet here.
Since image collection play a central role in the development of these techniques, the first evolution to look at is the evolution of the image collection. A first trend that we notice is the specialization of this collection. In 2017, a collection about gender prediction from hand images was collected. And this is not a single example. You can find plenty of image collection where both the images and the annotation become more and more specific. We also see a general trend of link of text with image. Visual question answering, for example, is a collection of image where multiple images are associated with one question, each image containing a possible answer to this question, as you can see below. We also see since a few years the apparition of image collection search engines. Since the number of image collection are growing exponentially, companies are developing engines to browse this collection depending on the type of image, depending on the type of task they are made for. And this really changes the circulation of this collection of images as the search engines and the internet platform have changed before the circulation of digital images. So we are entering a new era of circulation of this collection of these groups of image. The companies, of course, are major actors of this evolution as they gather, process, and press and spread most of the images that go through the internet. Another evolution concerning the program is the introduction of user control. The style transfer examples that we have given you in the introduction, the user simply inputs two images and has no much choice about the way the program, the algorithm processes the images. But you can see in the GAN paint example in the figure that you can select a feature and then have a pencil to draw some pieces of the image on which that you'd like to modify, on which you'd like to have sky, grass, or tree appearing. All these techniques are becoming a commodity, are becoming very easy to use for anybody, which has, of course, a huge impact of the circulation, because if everyone can modify these images and let them circulate off the internet, this will have a huge impact. The last trend in evolution is the evolution of search, which is one of the major means that we have to have access to image, search engines. Now that we have programs that characterize the images, all the image retrieval systems and algorithms are based on this categorization. So far, it was based on the annotation or metadata that the user associated to the images. But now, all kinds of representation of categorization produced by this program are used. And the future lies probably in the content-based image retrieval. Now we will discuss a few practical consequences of the use of these algorithms, of these programs, on the actual circulation of images. The first consequences impact all the images that are circulating on the internet platforms. For example, a publication in 2018 explains precisely how this machine learning algorithm, all these programs are used at Facebook, and specifically two Facebook programs, Lumos and Facer, are explained. The first one extract attributes and embeddings from an image, enabling algorithm to automatically understand it. The second one, the Facer, first finds all the faces in an image and then runs a user-specific facial recognition algorithm to determine the likelihood of this face belonging to one of the top-end friends of the user, in order to suggest which friend you might want to tag. So this is first practical impact on the circulation, and this shows how fine the categorization of the image is currently on these platforms. Second consequence is that these generated images are actually on the art markets. For example, the butcher son of Mario Klingemann is famous because it won several prizes and is sold on several internet galleries. And the author gives an interview where he explains from which collection this image, this artwork, was generated.
Pour entraîner la machine, il y a deux sources d'images du corps. L'une est la pornographie et l'autre c'est le sport. Je suis plutôt dans les ordis. Le sport, c'est pas mon truc.
A first consequence that we've already mentioned is the fragmentary circulation, the circulation of fragments of images like the style, the contents, or other attributes of the image. This example of a query Van Gogh style in a famous image web search engine shows you that this already impacts the circulation and the visibility of the image, since these algorithms have become commodities and are very easy to use by anyone. Another consequence is somewhere between the pastiche factory and the communication operation. A team led by Microsoft, ING, and researchers pretend to have recreated a work of a master with AI. AI meaning here artificial intelligence, but it stands here for most of the techniques that we've mentioned. As we said, they pretend to have distilled the artistic DNA of Rembrandt in an extensive database of his paintings. But essentially, it's just an automatic decomposition and recomposition of the pieces of Rembrandt with a lot of annotated data to create a new pastiche, a new fake. Another consequence, which is a bit more new and peculiar, is the circulation of distilled image collection into programs. As we've said, these new programs are able to distill, to compress the information of a big collection of images in order to generate new ones without storing the initial image. Now there are banks of image generation programs on the internet, and you can download and use any of these programs without having the initial image collections. There are even interactive modes on the internet to use these programs and to generate a new image which has been distilled from some image collections. In some sense, the image of these collections circulates through the new image you have generated, but there is no possible track of which part of which image was distilled and recomposed into this new image. Through this presentation of these new automatic image manipulation algorithms and programs, we wanted to show the extremely fast evolution of the techniques and the rapid impact on the practical circulation of image, as these algorithms are on the edge of being accessible to everyone. They induce new form of circulation that we've shortly presented. The images are fragmented, collections are distilled, and allowed to generate new images. A particular phenomenon about this is the big companies' focus on art. Apple, for example, hired the researchers that are at the origin of the style transfer programs we've shown you. The next Rembrandt project was led by Microsoft. Google leads the Magenta TensorFlow software to make music and art with machine learning. The question is whether it's essentially for image and communication purpose, or if there is a real will of these actors to have an impact on the circulation of the art image meant in general.